Unit 9, Section 7 is very similar to what you did in Section 6, except the main idea is that you're going to be doing something called a one-sided proof. These are not like the proofs that you had in geometry where you had two columns and you would have to state something and give a reason. It's not that kind of proof. It's a proof that looks something like this. It will give you an equation, and just so you are aware, whatever it says, this is equal to 1, you are going to prove that this is equal to 1. And the way you're going to prove it is by doing the same exact things that you were doing in Section 6. The only issue, it's a one-sided proof. A one-sided proof is different than how you solve problems normally. How is it different? It's different because you are not allowed to add something to both sides. You are not allowed to subtract something from both sides. You are not allowed to multiply or divide something to both sides. If you're working a one-sided proof, what it means by its title is you are only allowed to work one side of the equal sign. And you're supposed to turn that thing into the other side. Meaning, you're going to turn this into 1. Or, you're going to turn this into cosecant of x minus cotangent of x. Or you're going to turn this side into that. Or you're turning this side into that or that side into that. You will not do both sides. You are only going to work one side and turn it into the other. That's what we're going to be doing. That's the main idea of this last section. How you're going to do it? You will simplify, or you will use any of the identities that you had, or you will multiply by an equivalent expression of 1. Not like 1, but more like I might multiply by sine over sine. Sine of theta over sine of theta. Or you might multiply by tangent of theta over tangent of theta. That is the same thing as multiplying by 1. These are the 3 things you can do. You can't do anything else other than those 3 things. So with that being said, I'm going to be showing you how to do one-sided proofs. You can start with either side, but I recommend starting with the side that you think is messier or harder to work with. Always pick the harder side because you're used to simplifying, okay? Now, I have a couple of interesting jokes, but there's a new form of identity theft. If you go and steal some trig identities, I guess that's identity theft as well. I don't know. Kind of a difference. But I saw it, I go, oh, that's perfect. We need to talk about that since they know those identities. The main idea is the one-sided proofs, but there are also other ways you can simplify using something what I would call the minor identities. Most of the questions that you have on the test will come from Section 6. But there's a few that will come from these minor identities. They are called even and odd identities. And the other one, cofunction identities. Those are your minor ones. These are the ones that we rarely use, but there'll be a couple, just not a lot. If you have limited brain space, some of you know who you are, and you can only memorize so many things, always memorize your reciprocal identities and your Pythagorean identities and your quotient identities first. Those are the ones that most of your problems come from. If you're going to sacrifice memorizing anything, I would sacrifice these ones. But I promise you there'll be at least 1 or 2 on the test. Not a lot. Maybe only 1, maybe only 2. Okay? First ones, even and odd, is a way to go from, let me zoom in, is a way to go from a negative angle into a positive angle. If you are given a negative angle for any of the trig functions, all 6 of them, and you go to a positive angle, sometimes it switches sign. Like, well, let me show you what I mean. This is a positive, then it switches to a negative, positive switches to a negative, positive switches to a negative, positive switches to a negative, or sometimes it stays the same sign. Positive stays a positive, positive stays a positive. When you switch from a negative angle into a positive angle, which is what you have to do, if you know that these four functions are odd, those ones are the ones that will change sign. The ones that are even will stay the same sign. You don't need to know anything else other than that. That's the main idea for this. If you are a person who really goes, I really need to know why that works, it has everything to do with quadrants. Think about this. If you have a negative angle, let's call it angle negative u, because you're going in the negative direction from unit 8, and we were to switch to a positive angle u, it's the same distance, right? You would be switching from quadrant 4 to quadrant 1. Now let's think about that in terms of sine, cosine, and tangent. Sine, cosine, oh actually let me write that different. I'm going to write it cosine, then sine, then tangent. Cosine, sine, tangent. The cosine in quadrant 4 is positive, the sine is negative, and the tangent is negative, right? If you were to go from quadrant 4 into quadrant 1, what would happen? Cosine's positive, sine's positive, and tangent would be positive. Think about that. Cosine stays the same. Sine changes, so does its cousin. Tangent was a negative, switches to a positive. It switches sign. The odd ones will always change signs, including their cousins. The even one, which is cosine, and its cousin will stay the same sign. If it starts off as a negative, it stays a negative. If it starts off as a positive, it will stay a positive for evens. First set of minor identities are even and odd. Second set are something called co-function identities. It's a way to switch from sine to cosine, or cosine to sine, or from tangent to cotangent, or cotangent to tan, or from secant to cosecant, or cosecant to secant. In this example, I put pi over 2, but remember it's the same thing as 90 degrees. If you think about it, and you have a sine graph, which we've already talked about, you have a cosine graph, these two functions are very similar to each other. They're the same graph, except one is shifted. By how much? By 90 degrees. If I want sine and cosine to be the same thing, it's 90 degrees or pi over 2 subtracted by your angle, and that makes the sine the same as the cosine. If we just shift the sine to the left, they will be the same graph. If we shift the cosine to the right, it'll be the same thing as sine. And that goes for secant and cosecant and tangent and cotangent as well, just so you're aware. We'll be using those as well, but remember, those are minor ones. So, major idea for section 7, one-sided proofs. Then there's going to be some simplifying problems, which are minor. Let's talk about one-sided proofs. I'm not going to allow you to do these just yet. I recommend writing down what I'm about to show you. In a one-sided proof, you're only allowed to work one side. I always recommend pick the messier side. This side is messier. You cannot move anything to the other side, but you can simplify. You could multiply this out. I don't recommend that. If you see something squared, 1 plus tangent squared, do you know what that simplifies to? Using a Pythagorean identity, maybe number 2. 1 plus tangent squared of theta was equal to something. What's this equal to?
Secant squared.
So this is the same thing as secant squared of W because it's the same angle. I'm going to leave this one alone. I'm going to leave that alone. Notice I'm not touching the right-hand side. I need to turn the left side into 1. I know what secant squared is equal to using a reciprocal identity.
Cosine.
Not cosine.
Oh.
You're close.
1
1 over cosine squared is what we're looking for. And then if you're multiplying 1 divided by cosine squared times cosine squared, you're going to get cosine squared on top and a cosine squared on bottom. And guess what? Cosine squared divided by cosine squared is the same thing as 1. And that makes the left side equal to the right side. What is nice about these proofs is that I'm giving you the answer. The answer is this is going to turn into 1. You have to just prove to me that you know how to do it by using your identities as you go. Warning. Since I know that you know the answer is going to be 1, if I can't tell what you did to go from here to there, to there, to there, to there, if you try to go from here to there, you will lose almost all the points. -4 out of 5 points. I have to be able to tell what you did. Do not skip too many steps. I'm the one who grades these on the test, and so, therefore, if I can't tell what you're doing, or you skip too many steps, well, Mr. Prommel, I know that cosine squared is equal to what? Well, you're supposed to end with 1 equals 1. This is a full credit answer. This is what I want. Don't skip too many steps. Don't assume that I am going to be able to go inside your brain and know what you were thinking. I can only go off of what you write down. Gavin.
If you can't tell like which side is messy.
Well, then pick and go. Like this one, number 5. How many of you think the left side is messier, and how many of you think the right side is messier? Let's go. I think the left side is messier. Raise your hand. How many people think the right side is messier? More people say left side. Let's try the left side. This is 1 minus cosine of x, and we have to turn it, divided by sine of x, into that. We're not going to be touching this side. This side is going to stay cosecant of x minus cotangent of x. This 1 minus cosine of x is divided by sine of x, so they're both being divided by sine of x. In other words, this numerator is being multiplied by 1 over sine of x. And I haven't done anything that's to both sides. I can't move anything. All I'm doing is, instead of dividing by sine of x, this is in parentheses, and it's really times by 1 over sine of x, right? I'm just trying to simplify a little bit. Now I'm going to distribute this to here and to here. And some of you may not see it yet, but look at what we did. By taking the 1 and dividing it by sine of x, or multiplying right here, I know what this is equal to. By taking the 1 over sine of x and putting it over here, you have a negative cosine on top and a sine on bottom, and I know what that's equal to. Have I made the left side equal to the right side?
Yes.
can you follow my work in every single step and see beyond a shadow of a doubt that Mr. Promo knows why the left side is the same as the right side?
Yeah.
I went this way. Some of you might do it differently. Some of you might do this side and turn it to 1 over sine of x. And might turn this side into cosine over sine of x and then put them together because they have a common denominator. And guess what? Yours would go like this, to this, to this, and you can get the same answer, just in a different way. You can still get full credit if you do it your way, as long as it's correct. Sometimes you have no idea whether it's going to be the easier side or the harder side. The reason why I'm re-recording this in third period as opposed to first is because in first period I got stuck with number 14 the first time I tried it. I remember now how I do it because it was over a year since I've done this problem. Which side is messier? Which side would you work with first? Left side or right side? Left side people, raise your hand. Right side people, raise your hand.
Oh, come on.
Let's do it. We're going to leave this alone. We're not going to touch it. These two things are multiplying each other. I don't see a squared term. The only thing I know how to do is I know how to turn secant into something, which is 1 over cosine of b. And I know how to change cosecant into 1 over sine of b. So far, so good. Some of you are going to get real uncomfortable with this, but let's do it. Over here, you have two things that are adding each other. There is nothing adding on this side. But there is a way to get this side to have something that's adding. And it's right here, whether you know it or not. Let me put it in blue. Oh, Mr. Promo. I know what 1 is the same thing as. Something that's being added. It's the same thing as Pythagorean identity number 1. And some of you will not think to use it, but when you get stuck, look for an identity. 1 is the same thing as. What's the first Pythagorean identity?
Sine b plus sine b squared plus cosine squared.
How about sine squared plus cosine squared? Now think about why I did that. Think about why I did that. The reason why I did that was because this side has something being added. There was nothing being added here, and I thought to myself, the only thing that I know that's equal to 1 that's being added is Pythagorean identity number 1. This left side, we're still not touching it. We're leaving it alone. So now what I'm going to do is the same thing I did earlier. 1 over cosine of b times sine of b is multiplying sine squared of b plus cosine squared of b. Isn't that what that's doing? So I could then multiply this to that and have it on top, and then I could do the same thing over there, and then there'd be a plus sign in between. That might get me closer to what I'm going for. Okay, so now I'm going to take this and go up over here. Sine squared of b over now. My whole goal is to turn this into a tangent plus a cotangent. Will something simplify on this side? Does sine go into sine squared? Since that's all multiplication, this can reduce. I think I see tangent. Cosine of b, cosine squared of b, this is multiplication. I can reduce multiplication. I think I see cotangent. And what was I trying to get it equal to? I was trying to get the tangent of b plus the cotangent of b equal to tangent of b, cotangent of b. Look at that. Got a little complicated, right? We probably could have found an easier way if we were to have changed 1 into tangent squared, or maybe secant squared minus 1. There might have been a shorter way. This is not the shortest way. Just want you to see it. If that makes you uncomfortable, some people would go the other way. Some people would turn this into sine of b over cosine of b, and then find a common denominator and go from there. Lots of different techniques. Which brings us, remember, proofs, some of them are harder than others. That's why you'll get to practice some tonight. Then there's the simplified problems with some of the minor identities, like number 16. It has a negative angle. You have to change this negative angle into a positive angle. When you change sine of a negative angle to a positive angle, is it the same or is it opposite? That means this, instead of a positive sign, it's a negative sign of x. It changes sign up on top. That is called an odd function. This looks like a cofunction. This is the same thing as
Negative sign.
not negative sign.
Cosine.
Cosine of,
X.
which means that this simplifies to something else. There's those small little puzzles that come back using the minor identities. Last example. I see a cofunction identity. This turns into one of its other functions. What does the numerator turn into? Of what?
X.
Can't have it without the variable. Don't forget the angle, I mean. Cosecant, is that even or is it odd? So it's going to change sign from a positive to a negative when you switch from a negative angle to a positive angle. Instead of dividing by cosecant of x, you're dividing by 1 over sine or multiplying by its reciprocal. What does this become? Well, let me show my work. instead of I'm going to change this to 1 over sine of x. I'm multiplying by the reciprocal, which is negative sine squared of x. Hopefully this video was helpful for you. If it was, hit like, subscribe,
Comment.
or leave a comment if it's positive. If you have a criticism, you can do that too. Just be nice.